Now we will talk about another protocol called Address Resolution Protocol, ARP. But before that, we need to know that in any network interface, uh, we have to configure an IP address, and then there are two addresses associated to the interface. One at the data link layer that is called the MAC address that we already explained. Is typically an address of 6 octets, that is 48 bits. And the IP address, the IP version 4 address, is an address of the internetwork layer, and it's an address of 4 octets, that is 32 bits. And if you would like to know which address has an interface, for instance, in a Windows platform, you could type the command ipconfig with this option, and you will see the typical physical address with this notation, and the IP address with this notation, that is the decimal dot notation. The challenge is that in order to send, for instance, the data diagrams from one host or one node to other, the node, the host, need to know which is the MAC address associated with the destination IP address. Then typically in this diagram, in this network diagram, we could see that there are 4 nodes, 4 hosts. Each node has in his interface has a MAC address and has an IP address. Then when we need to talk, for instance, from this node to this other node, this node send a request, send a broadcast request to the others using a protocol called Address Resolution Protocol, asking for the MAC address associated with this, for instance, this IP address. And in that way, the destination, the destination node, the destination host, will receive, like the others, the ARP request, the Address Resolution Protocol request, and if he is identified in the destination IP address, he will answer only to the sender, in that case from C to B, with a unicast frame, not a broadcast frame, and responding with an ARP reply, an Address Resolution Protocol message reply. And in that way, this node could obtain the associated MAC address to the corresponding MAC address to the IP address to which the B node need to send an IP datagram, for instance. Then, in order to exchange those messages, we could use this protocol called Address Resolution Protocol, is a protocol that is encapsulated over the Ethernet 2 frames or Ethernet 2 service, data link service. And in order to identify the ARP request or ARP reply packets, here in the frame type field, the sending node have to specify this number. This number is in hexadecimal notation, but in fact this number is a number higher than typically 2000. Then this is the typical Ethernet 2 frame format. In that way, then the ARP messages could be exchanged across an Ethernet network, and this protocol message, this PDU, has several fields called hardware type, protocol type, hardware length, protocol length, operation, Ethernet MAC address, IP address, Ethernet, then Ethernet source, source MAC address, source IP address, destination MAC address, and destination IP address. In that way, then when B send the ARP request, the ARP request is sent encapsulated into a broadcast Ethernet 2 frame. Then all other stations will receive the ARP request, but in that ARP request, in this field, specify that is a request. In this field, specify that is a MAC protocol, and for instance, a MAC protocol in the layer 2 and IP protocol in the layer 3. The hardware length is 6 octets in this case, and the protocol length here is 4 octets in this case of the association between MAC addresses and IP addresses. And in the ARP request, B will specify here his own MAC address, that is this one, his own IP address, that is this one, and the destination IP address, that is this one. What the node B need to know, and that's why node B send the ARP request, is the MAC address associated with this IP address. Then when C recognize that the question is addressed to him, the node C will answer, sending an ARP reply or ARP response. In this field, the C will code the number that says that this is an ARP reply, and here in source MAC address, C will specify his own MAC address. Here C will specify his own IP address, and he will send this ARP messages, ARP reply message to this IP destination, that is this one, and this MAC address, that is this one. In that way, any node, any station in this local area network would obtain the information that that is needed in order to send IP messages encapsulated into Ethernet messages. When B will need to send an IP datagram to this destination, B will encapsulate the IP datagram into an Ethernet 2 frame, which the MAC destination is this one. And that's in that way the address resolution protocol could convert typically the IP addresses into the physical addresses or hardware addresses or MAC addresses. And those are all synonyms of the same address type of level 2. And finally, in order to perhaps see some kind of chart that reflect, in fact, the exchange, the protocol messages exchange, we could use this standard proposed by the E2T, the International Telecommunication Union, and this standard is called message sequence chart, and this is typically a generic chart, but in fact, in the case of ARP request and reply, we could represent the exchange of the messages, of the ARP messages in that way. In the sender station, we need to obtain the MAC address associated, for instance, with this IP address. Then this node will send a broadcast. This is the representation of broadcast. The unicast is represented by an arrow that finish just here. In this case, is a broadcast. But the broadcast, the Ethernet 2 frame broadcast, contain an ARP request, where the destination IP address is this, and obviously the destination MAC address is ignored. Is what this station would like to know. Then this station, like others, listen this broadcast, analyze this ARP request, see that the IP destination is himself, then this station will answer with a unicast Ethernet 2 frame addressed directly to this MAC destination address, and that unicast Ethernet 2 frame contain an ARP reply where the source IP address is this one, and the source MAC address is this one, and in that way, the station that would like to obtain this association addressing will obtain the information that the information needed. Once the ARP exchange of the request and reply is performed in the, for instance, in the node B, we could type this command ARP -A, and we will see that this node, this host, has obtained information of the associated MAC address to this IP address. Then, when this node will need to send a protocol, an IP message, an IP datagram to that destination host, this platform will encapsulate the datagram address to this destination into an Ethernet 2 frame destinated to this MAC address.